Hello guys, welcome. Today we are here to discuss about a question called Count hills and valleys in an array. You are given a zero indexed integer array nums and index I is part of a hill in nums if the closest non-equal neighbors of I are smaller than nums of I. Similarly, index I is part of a valley if the closest non-equal neighbors are larger than nums of I. So the current index is part of a valley if closest numbers are greater than ith value, and they are part of a hill if closest numbers are less than ith value. That's all. Very simple one. So adjacent indexes I and j are part of the same hill or valley if nums of I. So if you have same values, like for example 1, 1 and 6 and 5, these two are part of same valley, like same valley. So that's what they're saying. They're part of same valley or same hill. Adjacent indexes. Okay. Adjacent indexes I and j are part of same hill or valley if they are equal. Note that index for an index to be part of a hill or valley, it must have a non-equal neighbor of both left and right index. We need to return number of hills and valleys in nums array. Okay. So let's see the example, guys. We need a simple thing. We need to count number of hills. Hill is nothing but like the adjacent values are bigger values. If valley, adjacent values are smaller. So let's see. 2 and 4. So for 2, right side we have 4, but left side nothing is there. So we can't count here. So it's not a hill or valley. Now we'll go to 4. Left side is bigger, smaller value. Right side is also a smaller value 1, which means this is a hill. This is a hill. Okay, good. Now we got one hill. We got one hill. Let's erase this one again. Now next one is 1. Left side is 4, bigger value. Right side is 1, same value, which means these two are part of same valley. Same valley. So what is the right side of 1? Maximum of right, maximum, like first maximum of right side of 1, 6. So, so here if you observe guys, okay, once left side we have 4, which is a bigger value, which means this is a valley. Good. But right side we don't have 1. We have 1, which means these two are belonging to same valley. So here we have 6. So this 4, 1, 1, 6 is a valley. Not just 4, 1, 1 guys, because these two are same values, which means they belong to same valley. So count will just become 2. Now we need to go to 6. If you observe 6, left side is 1, right side is 5, which are smaller values. 6 is a hill. So 1, 6, 5. Left side is smaller, right side is smaller. So count becomes 3. Count becomes 3, guys. So here the main point you need to understand is wherever we have same values, they belong to same hill or same hill or same valley. Same hill or same valley. Right? But how you will identify they are belonging to same hill? Right now, when you are here, the left side value is 4. But when you are here, what should be the left side value? It should not be 1 because they are same hill. So it should be 4. It should be 4, right? The left side value should be 4. Obviously, right side value we can keep track. Like the right side value is 6, right? So we need to keep track of previous value. Previous value. Why? The purpose of having the track for previous value is when you have same values, we need to run a for loop to find out the value. That's what the issue here. That's what the issue here. That's all, guys. I hope the point is clear to you people. Right? Very simple one. If the current value is this one, okay. If the previous value, what is the previous value for this one? 4. Next value is 1. So we can't count here. It's not a, we can't count here. We need to go further more. Why? Because they are same. We should go and find here. Now 1 and 4. One's previous value is 4. Next value is 6. So I can count 1, 4 and 6. This is a valley because 1 is less than 4 and 1 is less than 6. Then it is a valley, right? When we call it as a hill, if your current value is greater than previous value and current value is greater than I plus 1 value, I plus 1 value, you might be thinking why we are taking I plus 1 here, why we are taking previous. Why? The purpose of taking previous is if they are same, we are not considering the count here, we are simply moving to the next value. So when you move to the next value, the left side value is not the bigger one. Left of left we need to consider because they are same. That's all. Nothing much here, guys. Don't worry. Okay. I hope this is clear to you people. Now let's write the code for this. Like we need to have a count here, which is 0. Now we need to iterate on the numbers. Int I equals to from where we will start. For 0th index, it's not a valid. So 1 we need to start it. I less than nums dot length I plus plus. Okay. Last value is also not mandatory to go. Okay, let's see. So what is the previous value initially? Previous value is initially nums of 0. Nums of 0 is the previous value. What we need to see? If your current value, which means nums of I is less than previous value and nums of I is less than next value I plus 1, then this is a hill, which means count plus plus. Count plus plus, right? But we have one more thing also. We have one more thing also, guys. If you remember, we have two things. One is a hill, one is a hill, valley and hill. So if the current value is less than previous and nums of I plus 1, this is a valley. We need to root for hill, nums of I greater than previous and nums of I greater than nums of I plus 1. We should not go to last index, guys, because it's not a valid one. As you know, 5, we don't have any right side value, right? And this is how we do. But we need to keep track of this one. If you remember here, for this one, previous is 4. Even for the next one, the previous should be 4. We need to keep track. How you will keep track? So how you will keep track is if nums of I not equal to nums of I plus 1. If the next value is not same as current value, then only update the previous. Then only update the previous to nums of I. Okay, what I am doing here is, guys, very simple one. When you are at this place, previous is what? Previous is 4. Now you need to go to the next value. Next value is also same now. Next value is also same as 1. So don't update this to 4. Like don't update the previous. It should be same. So that's what I'm doing. If the current value is not equal to the next one, then only updating the previous. Then only updating the previous. And at then what we need to do? At then what we need to do is return the count. Return the count. That's all. Let's run this. That's all, guys. This is how we solve. We are simply checking the left and right. Instead of left, we are checking a previous. The purpose of checking the previous is we have a duplicate values, continuous values in the array. That's all. I hope you understand this one. We'll meet in the next video. Until then, see you guys.